So we're going to review the equivalent forms method for solving a system of equations. It is important to note that this is a subset of the substitution method for solving a system of equations. So in the future, when we refer to always using substitution or elimination, if you choose to use this, it would be considered using the substitution method. So first of all, let's go to how we started today, when we first learned the transitive property. If you know that A is equal to 6, and you know that A equals C, could you determine what C equals? Well, because A equals 6 and A equals C, hopefully you guessed that C has to equal 6. This is the transitive property because you're saying that because A equals 6 and A equals C, then 6 has to equal C or C has to equal 6. You're transitioning that equality. Let's try another one. This time, if B equals 2x and we know that B equals D, what does D have to equal? You're right. It has to be 2x. Last one. If y is equal to 3x minus 1, and we know that f of x is really just the function notation for y, what does f of x equal? Awesome job. You should have gotten that f of x is equal to 3x minus 1. So let's go on to these two equations. We have y equals x plus 3, and we have that y equals 3x plus 1. Well, if we know y equals both of these, that means that they must equal each other at some point. In fact, when we solve for where these two have in common, these two equations have in common, we're actually looking for the intersection point. So I can set x plus 3 equal to 3x plus 1, and now it looks just like a practice problem that we've been doing for Unit 9. Let's go ahead and get x by itself. To do that, we could subtract x from both sides. So we're left with 3 alone over here. 3x minus 1x gives us 2x left, and then we still have this plus 1. The next step would be to subtract 1 from both sides. 3 minus 1 is 2, and then we still have our 2x. You're right, the final step is going to be to divide everything by 2. So I get that x is equal to 1. Now, this is where I was talking about in the steps to solving systems of equations, where we combined the two variables. Where we combined it is right here, and then we literally solved for one variable. So we found that x equals 1. If you return back to your 3 steps for solving a system of equations, you'll notice that the next step would be to plug this back into one of the original equations and solve for the other variable. So let's go ahead and plug it back in to this equation for x. Thus, we are going to get y is equal to x, which is 1, plus 3. Well, 1 plus 3 is 4, so that means that y equals 4. Therefore, these two lines should cross at 1, 4, because we saw that x was 1 and y was 4. But remember, the third step is always to do your check step. So let's go ahead and do the check step here. We need to use the other equation, so this equation right here, and we need to plug in these two values for x and y. If y is 4, we replace y with 4, and then we replace x with 1. So we get 3 times 1 plus 1. Well, 4 does, in fact, equal 3 plus 1, so that checks out. Awesome job. Let's quickly look at how this looks when it is graphed. Let's see here. I'm going to make that a little bit smaller. If you need to, you can definitely pause when it's bigger. But here I graphed the two lines. You can see where they cross, right here. In fact, if you look, that is the point 1, 4, which is the point that we found for their solution. So, when you are solving a system of equations, you're really looking for where these two lines, or the two equations, intersect on a graph. So this is called the equivalent forms method. Remember, the 2 steps for the equivalent forms method are as follows. The first step is you need to solve both equations for either x or y. You need to make sure that whichever one you solve for, you're doing that for both. You cannot solve one for x and one for y. They either both need to be for x or both need to be for y. Then the second step would be to set these two equal to each other and solve. So we're going to go ahead and do one more example together. For our example, we're going to look at the equation x plus y equals 3 and x minus y equals -5. First of all, you'll notice that both of these equations are written in standard form. So we need to manipulate them to get either x alone in both equations or y in both equations. This does happen to be rather easy in this case for both of them, so it doesn't matter which one. But sometimes it's definitely easier to do one variable over another, so you may want to consider that as you're choosing which variable to solve for. This top one, if we want to get x by itself, we have x plus y equals 3, we can subtract y from both sides. Then we get x is equal to 3 minus, that's a minus sign, y. For this one, if we want to get x by itself, and we're starting with x minus y equals -5, we could add y to both sides. Thus now we get x is equal to -5 plus y. Now we got our two x's alone. Awesome! Because now we can move on to number 2 in our equivalent forms method. Remember, number 2 is to set these two equal to each other and then solve for the variable that we still have in there. So we are going to set 3 minus y equal to -5 plus y. Well, obviously we need to solve for y, so let's go ahead and get y alone on one side. To do that, we could add y to both sides. Then we get 3 is equal to -5 plus 2y. Now we need to move this -5 to the other side. To undo a -5, you would need to add 5 to both sides. Thus we get 8 is equal to 2y. So then our final step is going to be that you need to divide both sides by 2. So you see that y equals 4. Awesome job solving for the one variable. But we're only halfway there. We still need to find what x equals. So we can take what we just found for y and plug it in to one of these two original equations. Keep in mind that the two original equations are the two written up here in black, not the ones that we solved for x in. So if we plug this back in, I'll just choose the first one. We're going to have x plus y, which we now know is 4, equals 3. To solve, we would need to subtract 4 from both sides. Well, 3 minus 4 is -1, which means that x must equal -1. Therefore, these two equations cross at the point -1, 4, because our x value is -1 and our y value is 4. Again, you should do your check step where you plug these two values in to the other equation. The equation we didn't use is the bottom one, the x minus 1 equals -5. So, x is -1, and then we need to subtract y, which we found out was 4. We need to make sure that that's equal to -5. Well, -1 minus 4 is -5, which is definitely equal to -5. So that checks.